We continue now with case number 2, wherein the integrand contains the form given now by the square root of u squared minus a squared. So for this case, we'll use here this substitution, u equal to a secant theta, where theta lies in this domain. So notice na yung angles na kailangan natin lies either, yung terminal side niya lies either on the x-axis or in quadrants 1, 0 to pi over 2, or 3, pi to 3 pi over 2. So using this substitution, u equal to a secant theta, again, yung du is equal now to a, derivative ng secant with respect to theta would be secant theta, tangent theta, d theta, and so the square root of u squared minus a squared is equal now to the square root of u squared is a squared secant squared theta minus a squared, which is equal now to the square root of factoring out a squared. We have here the square root of a squared times secant squared theta minus 1. Using our trigonometric identities, secant squared theta minus 1 is tangent squared theta. So we're taking the square root of a squared multiplied by tangent squared theta. And so you have here the square root of a squared is a, since a is positive, while the square root of tangent squared theta would be the absolute value of tangent theta. Pero yung theta na kinukuha natin, or in quadrants, yung terminal side niya lies in either quadrants 1 or 3. So positive dun yung theta, yung tangent of theta. So this is equal now to a tangent theta. So same problem with case number 1. How do we retrieve the rest of the trigonometric functions? So again, yung ginamit natin ng substitution is u equal to a secant theta. So yung secant theta natin for this case is u over a, which is the hypotenuse divided by the adjacent side. So if we're taking a look here at this triangle, and sabihin natin for this case na ito sa theta, then the hypotenuse is u, the adjacent here is a, tapos yung magiging opposite side niya would be the square root of the hypotenuse squared minus the leg squared. And so you could retrieve now tangent, cotangent, say cosecant as well, sine and cosine. So let's take a look here at this example. Let's find here an antiderivative for the square root of x squared minus 2x all over x minus 1 squared. So if you notice here, yung gusto natin is meron tayong square root of u squared minus a squared or u squared minus a squared lang. But notice, x squared minus 2x is not yet written in that form kasi kung sabihin mo na yung x squared lang yung u squared, and then yung magiging a squared mo should be 2x, pero again, a squared should be a constant. So, to deal with this, from time to time, kailangan natin mag-complete ng square. So, recall here na kapag meron kang ax squared plus bx plus c, yung kailangan mo i-add at i-subtract to complete the square would be b squared divided by 4a. Not to confuse that with yung a na hinahanap natin to the square root of u squared minus a squared. So, to proceed here, by completing the square, uh, take note here na yung integral of the square root of x squared minus 2x all over the quantity x minus 1 squared with respect to x is now equal to the integral ng square root ng x squared minus 2x. Again, to complete the square, kailangan natin yung b squared, which is 4, divided by 4a, a is 1, so that would be 4 over 4. So mag-add and subtract tayo ng 1. Of course, yung plus 1 would be would be grouped with x squared minus 2x. And then meron tayo ditong minus 1. and then all over x minus 1 squared dx. And so this is equal now to the integral of the square root of x minus 1 squared, x squared minus 2x plus 1, and then minus 1 all over x minus 1 squared dx. So what we have here is si A is 1, tapos yung u na gagamitin natin dito is x minus 1. So ano yung substitution natin? So here, we let, again, u is x minus 1 equal now to, again, the form is u squared minus a squared. So papalitan natin siya by a is 1 multiplied by secant theta, which means here that taking the derivative of both sides, yung derivative ng left would be 1 lang multiplied by dx equal now to the derivative of the right with respect to theta. So that would be secant theta, tangent theta, d theta. And so, what do we have? The integral now of the square root of x minus 1 squared and then minus 1 all over x minus 1 squared dx is now equal to the integral of, again, kapag yung u squared minus a squared, yung u pinalitan mo by a secant theta, yung square root of u squared minus a squared would be replaced now by a multiplied by tangent theta. So, yung square root ng x minus 1 squared minus 1, again, pa-verify na lang, mapapalitan natin yan by tangent theta. Tapos, yung x minus 1 squared sa denominator, again, x minus 1 is secant theta. So, that would be replaced now by secant squared theta. And then dx is replaced by secant theta times tangent theta d theta. And so, to simplify, this is now equal to the integral of, meron akong tangent squared theta sa numerator, secant theta divided by secant squared. So, meron pa akong secant theta sa denominator. And so, yung goal natin is to integrate now tangent squared theta over secant theta with respect to theta. For this case, pa-recall na lang, coming from the previous lesson, na si tangent squared theta pwede nating palitan in terms of secant. So, this is replaced here by secant squared theta minus 1 divided by secant theta d theta. And so, you want here to find an antiderivative for secant squared theta over secant, that would be secant theta, minus 1 over secant theta. 1 over secant is cosine theta, d theta. And so, this is now equal to antiderivative of secant theta is ln absolute value of secant theta plus tangent theta minus the antiderivative of cosine theta is sine theta, and then plus the constant c. And so we revert this now back to x. Again, yung substitution natin coming from the previous page would be x minus 1 equal to secant theta. And so using a right triangle, oops, di siya right. Yan, medyo mukhang right na. Kung ito yung angle theta natin, again, secant would be the hypotenuse, x minus 1, divided by the adjacent. Adjacent natin dito is, pwede mong isipin na 1, so over 1. And so, yung opposite side, using the Pythagorean theorem, is the square root of x minus 1 squared and then minus 1. And so, this is equal now to ln, absolute value. Again, secant theta is x minus 1 plus yung tangent theta natin is the opposite, x minus 1 squared minus 1 all over the adjacent, which is 1. And then minus, for sine theta, that would be the opposite, square root of x minus 1 squared minus 1 all over the hypotenuse, which is x minus 1, and then plus the constant c. And so we have here this final answer. Let's proceed with another example. Let's have here instead the definite integral from e squared to e to the fourth of ln squared x minus 4 divided by x ln x. So, notice that for this item, medyo clear naman siya na meron kang ln squared x tapos 4. So, yung form natin is u squared minus a squared. So, here, we note that yung u natin is ln x and yung a natin dito is 2. So, we let yung u natin once again is ln x. So, we let u, which is ln x, equal now to a, which is 2, multiplied by form natin is u squared minus a squared. So, that would be secant theta. Then, yung derivative ng left with respect to x would be, again, 1 over x and then dx equal now to the derivative of the right with respect to theta. So this is equal now to 2 multiplied by secant theta, tangent theta, and then d theta. Tapos yung square root ng ln squared x minus 4, papalitan natin siya by 2 tangent theta. So, notice na since meron kang definite integral, tapos papalitan natin yung integral natin in terms of theta, then kailangan palitan din natin yung e squared saka e to the fourth in terms of theta. Pero, again, using our substitution, we have here the following. So, again, moreover, kapag yung x natin dito is equal to e squared, then, what do we have? Again, from the substitution, meron kang 2 secant theta equal siya kay ln x. So, that would be ln ng e squared. Pero yung ln ng e squared is 2 ln e. ln e is 1. So, that would be equal now to 2, which means here that secant theta is equal now to 1. So, anong value ba ng theta yung mabibigay sa atin ng secant ng 1? Again, pa-recall na yung theta na kinukuha natin dito, nasa quadrant 1, 0 to pi over 2, sa quadrant 3, just pi to 3 pi over 2. And so, since positive si secant, nandun ka sa may x-axis, or nasa quadrant 1, so this would be equal now to a theta of 0. While, if you have here x equal now to e to the fourth, then similarly, 2 secant theta is equal now to ln e to the fourth. So this is equal now to 4, which means here na yung secant theta natin ay equal to 2. Or yung cosine theta mo, which is the reciprocal, ay equal to 1/2. So for a secant theta of 2 or a cosine theta of 1/2, yung theta natin dito would be pi over 3. So thus, what do we have now? We have the integral from e squared going to e to the fourth of the square root of ln squared x minus 4 all over x ln x dx. This is equal now to the integral. Again, e squared would be 0. E to the fourth would be replaced by pi over 3. Yung square root ng ln squared x minus 4 is replaced by a tangent theta. So this is given by 2 tangent theta. Tapos, yung ln x natin sa denominator, again, ln x is 2 secant theta. While, notice here na meron tayong dx saka meron kang 1 over x. So, yung dx saka yung 1 over x is precisely this portion. So, this is replaced now by 2 secant theta tangent theta d theta. Oops. We have here 2 secant theta tangent theta d theta. And so, to simplify, we have here the following. So, meron ka ngayong 2 integral from 0 to pi over 3 ng tangent squared theta with respect to theta. And recall, coming from trigonometric integrals, napapalitan natin si tangent in terms of secant. So we have here 2 integral from 0 to pi over 3 ng secant squared theta minus 1 d theta, or that is, this is equal now to 2 times antiderivative ng secant squared theta is tangent theta minus antiderivative ng 1 is theta, evaluated from 0 to pi over 3. Or that is, this is equal now to, kapag yung theta mo ay pi over 3, meron kang 2 times the quantity. Tangent pi over 3 is square root of 3 minus theta is pi over 3. While when you have here a theta of 0, tangent theta is 0 and theta is 0. Or that is, this is our final answer. We have here 2 square root of 3 minus 2 pi over 3. And this ends part number 2 of this lecture. Please proceed to the next clip for part number 3.